So, we all hear this term artificial intelligence, or AI. It's this grand idea of teaching computers to think, to reason, to be, well, smart, like us. But that immediately brings up a huge question.
How do you actually do it? How do you get a computer to learn from experience instead of just blindly following a rigid set of instructions someone programmed into it? Well, the answer is a field that has completely, and I mean completely, reshaped our world.
And that answer is machine learning, or ML for short. Here's the best way to think about it. If AI is the destination we're all trying to get to, a truly intelligent machine, then machine learning is the engine that's going to get us there. It's the how behind the wow.
To really wrap your head around this, let's use a really simple analogy, something we can all relate to. Teaching a child with flashcards.
Okay, so let's invent a character for our machine. We'll call him Alex. Our mission is to teach Alex a very simple task, to tell the difference between a dog and a cat. Now, here's the crucial part. With machine learning, we don't give Alex a rule book. Instead, we give it examples, a giant digital stack of flashcards.
The process is really straightforward but incredibly powerful. We show Alex a picture of a golden retriever and tell it, this is a dog. Then a picture of a Siamese cat, and we say, this is a cat. And we just keep doing this, over and over and over again. Thousands, sometimes millions of times, with every kind of dog and cat you can possibly imagine. Now, at first, Alex's guesses are just completely random. It's basically flipping a coin.
But here's where the magic starts to happen. With every single guess and every single correction we give it, Alex makes a tiny adjustment to its internal logic. It starts to pick up on patterns. It starts to notice, hey, a lot of these dog pictures have floppy ears and longer snouts, or these cat pictures often have pointy ears and different shaped eyes. And this is so important. Alex isn't just memorizing the photos. It's learning the underlying features that define what dogness and catness really are.
And that right there, that whole process of feeding a machine labeled examples and letting it figure out the patterns all by itself, that, my friends, is the absolute core of what machine learning is.
In fact, we can boil this whole thing down to a simple 3-step recipe that applies to pretty much every machine learning system out there in the world today.
So, step 1, you need the data. For us, that's our huge stack of labeled cat and dog flashcards. Step 2, you need the algorithm. Think of the algorithm as the method or the strategy that Alex uses to find all those important patterns in the data. And when you mix the data with the algorithm, you get step 3, the model. The model is the final output. It's the trained brain that holds all that learned knowledge. And now, it's ready to go to work.
So what do we do with this finished model? Well, we use it to make predictions. This is the payoff. We can now show our model a brand new photo, something it has never ever seen before. Let's say it's a corgi, and it can use everything it learned to make an educated guess. It'll look at the features and predict, yep, that's a dog.
Now, I know this whole thing might sound a bit abstract, but I guarantee you interact with this exact 3-step recipe every single day. Let's look at a couple of examples you'll definitely recognize. First up, your email's spam filter. Have you ever stopped to wonder how it just knows that an email offering you $1 million is probably junk?
Well, it's our 3-step recipe in action. The data was millions upon millions of emails that people just like you and me manually marked as spam or not spam. The algorithm then churned through all of that data to find patterns like suspicious-looking links or specific keywords that pop up all the time. The result? The model that lives in your inbox right now, predicting if each new email is junk or not. Okay. Here's another one you use all the time, automatic photo tagging. In your phone's photo gallery?
How is it that you can just search for the word beach and it instantly pulls up all your vacation photos? It's the same recipe. The data was a massive library of images, all labeled by humans with tags like beach, sunset, dog, you name it. The algorithm then studied all those pictures to learn the visual characteristics of a beach. And now, the model on your phone can look at a picture you just took and predict the right tags for it, all on its own.
So let's just zoom out for a second and look at the big picture. What does all of this really mean for how we build technology?
What we're talking about is a fundamental shift. The old way of programming was all about writing explicit, hand-coded rules for every single possibility. Can you imagine trying to write a rule for every type of cat in the world? It would be impossible. The ML way just flips that whole idea on its head. Instead of giving the computer the rules, we give it the data and the answers, and we let the machine discover the rules for itself. It's a real game changer.
At the end of the day, machine learning is the most practical, powerful, and successful path we currently have to achieving that bigger dream of artificial intelligence. It's the modern alchemy that turns these vast oceans of raw data into real, usable knowledge.
But there is a catch. This whole idea, our flashcard analogy, it all depends on having those nice, neat, labeled flashcards to learn from in the first place. So that begs a pretty big question, right? What happens when your data is messy? What happens when you don't have any labels at all? Well, that's a whole other fascinating story, and it's exactly what we're going to explore in our next explainer.